Are you prepping for an interview where they might quiz you with an object-oriented programming, or OOP for short? Well, you're in luck. Today we're going to cover some of the most common OOPS interview questions that could come your way. Whether it's understanding the difference between a class, an object, or explaining concepts like inheritance, polymorphism, encapsulation, or data abstraction, I've got you covered. By the end of this video, you'll be well equipped to tackle those OOPS questions with confidence. So let's dive in and get you ready to ace that interview. But before we begin, make sure to like and subscribe to Upgrad's channel and hit the bell icon so you never miss an update from us. Question number 1. What is object-oriented programming? This is among the most basic OOPS interview questions or object-oriented programming interview questions. Object-oriented programming refers to the programming paradigm defined using objects instead of only functions and methods. The objects contain data called fields or attributes and methods that provide the logic or supporting code. It provides capabilities such as inheritance, polymorphism, encapsulation, and abstraction. More simply, this is the approach used in developing applications emphasizing objects. The object is an entity containing data as well as code, which allows the binding of data with code. Object-oriented programming has various benefits. It is instrumental in breaking down a huge problem into its simple solvable chunks. For instance, for each mini problem, the programmers write a class that does what is required. Question number 2. What are the main features of object-oriented programming? This is one of the most commonly asked OOPS interview questions. In this OOPS interview question, make sure you list the 4 main features. Number 1. Inheritance. It enhances the code's ability to reuse existing objects. This feature allows new classes to inherit properties and behaviors from existing classes. It promotes code reusability by enabling the creation of a hierarchy of classes where subclasses inherit characteristics, methods, and attributes from the parent classes. Inheritance facilitates the extension and modification of existing code without rewriting it entirely, enhancing the code's ability to reuse existing objects and reducing redundancy. Number 2. Encapsulation. It enhances modularity. It makes sure to keep routines separate and avoid any conflict. Encapsulation emphasizes the bundling of data and methods that operate on that data within a single unit known as an object. It promotes modularity by hiding an object's internal state and implementation details from the outside world. By keeping routines separate and limiting access to the certain parts of the code, encapsulation helps prevent conflicts and unintended interface, thereby enhancing code maintainability and flexibility. Number 3. Polymorphism. It allows new shapes to be easily integrated. Polymorphism allows objects to take multiple forms and enables different objects to be treated uniformly through a common interface. It allows the integration of new shapes or forms without altering the existing code base significantly. This feature simplifies code design by enabling objects to be manipulated and used interchangeably, promoting flexibility and scalability in the software architecture. Number 4. Data abstraction. This ensures that only essential information is displayed and the details are hidden. Data abstraction focuses on displaying only essential information while hiding the underlying implementation details. It allows developers to create abstract representations of real-world objects by emphasizing what an object does rather than how it does it. By defining clear interfaces and hiding complex implementations, data abstraction simplifies the interaction between different system components, enhancing code readability and eases maintenance and modifications. While answering these types of OOPS interview questions, make sure not to suffice your response by only mentioning the features. Instead, always say at least one line of the information about the features. Question number 3. What are the advantages of object-oriented programming? Object-oriented programming offers several advantages that make it a popular choice for designing and building software systems. These advantages contribute to the creation of code that is more modular, maintainable, and scalable. Here are some key benefits. Number 1. Modularity through encapsulation. Encapsulation bundles the data and the methods that operate on the data into a single unit called class. This modular approach allows developers to isolate different parts of the program, making it easier to manage and understand. Changes to one part of the program are less likely to affect the other parts, reducing the risk of bugs. Number 2, code reusability through inheritance. Inheritance allows new classes to be derived from existing classes, inheriting their attributes and methods. This promotes code reuse as common functionality can be written once in a base class and reused across multiple derived classes. This not only reduces code duplication but also simplifies maintenance. Number 3, ease of maintenance and upgrades. OOP's modular structure makes it easier to maintain and update code. When new features are added or bugs are fixed, changes can often be made to individual classes without affecting the entire system. This ease of maintenance is especially important in large, complex software projects. Number 4, scalability and manageability. OOP allows for the design of complex systems by breaking them down into smaller, more manageable objects. This makes it easier to scale the system as new objects and classes can be added without disrupting existing functionality. The clear structure and organization of OOP make large systems more manageable. Number 5, abstraction and simplification. Abstraction allows developers to focus on high-level functionality without getting bogged down by low-level implementation details. By hiding the complex inner workings of objects and exposing only the essential features, OOP simplifies the development processes and makes it easier for developers to collaborate and communicate. Number 6, polymorphism for flexibility. Polymorphism allows objects of different classes to be treated as objects of common superclass. This enables flexibility in code design as the same method can work with different types of objects, reducing the need for multiple method implementations. Polymorphism supports the concept of write once, use anywhere, making code more adaptable and extensible. Number 7, improved productivity through code reuse and modularity. By enabling code reuse, modularity, and clear class structure, OOPs can significantly increase developer productivity. Reusable classes and objects reduce development time and allow developers to focus on building new features rather than reinventing the wheel. Number 8, improved collaboration and teamwork. OOP structure makes it easier for multiple developers to work on the same project simultaneously. Different classes and modules can be developed independently and integrated later. This parallel development approach is crucial in large teams and complex projects. Number 9, real-world modeling. OOPs is particularly effective in modeling real-world entities and their interactions. By creating objects that represent real-world things or concepts, developers can design systems that are intuitive and easy to understand, making the software more user-friendly and aligned with the user requirements. Number 10, security through encapsulation. Encapsulation can also enhance security by restricting access to an object's internal state. By controlling how data is accessed and modified through methods, OOPs can prevent unauthorized or unintended changes, protecting the integrity of the object and the system as a whole. Number 11, ease of troubleshooting and debugging. With OOP, errors and bugs are often isolated within specific objects and classes. This isolation makes it easier to pinpoint the sources of issues and resolve them without affecting the rest of the system. Number 12, support for design patterns. OOP encourages the use of well-established design patterns like singleton, factory, observer, etc., which provide proven solutions to common software design problems. These patterns help in creating robust, reusable, and maintainable code structures. Overall, the advantages of OOP lie in its ability to produce code that is clean, modular, and adaptable, making it ideal for both small projects and large-scale enterprise applications. Question number 4. What is structural programming? This is also among the top searched OOPs interview questions commonly asked by panelists and interviewers. Structural programming refers to the traditional method of programming, which is based on functions. The overall program logic is divided into functions to provide a logical structure. It is based on a top-down approach. Structural programming is suitable for easy to moderately complex problems. Question number 5. What is a class? A class defines the template or the definition of an object. It is used for creating objects at runtime. It provides the data structure, provides initial values for the attributes, and methods that provide the logic for the intended behavior of the object. The class does not consume memory at runtime. A class refers to a logical entity. For example, a vehicle may be defined as a class. Question number 6. What do you mean by an object? When preparing OOPS concepts for an interview, make sure that you are thoroughly familiar with this topic. This is among the commonly asked OOPS interview questions for experienced candidates. An object refers to the runtime instance created from the class during program execution. Objects can refer to real-world entities that have attributes or properties and methods to support the behavior. Objects consume memory space when they are initialized. The objects are the first thing the programmers think of while designing. The objects are the class instances that allow the programmers to make use of variables and methods from inside the class. Question number 7. Is it always necessary to create objects from class? No, it is possible to call a base class method if it is defined as a static method. In object-oriented programming, classes serve as blueprints or templates for creating objects. Static methods in classes marked by the static keyword don't require object creation. They're associated with the class itself and can be called directly using the class name, bypassing the need for object instances. Question number 8. What is a constructor? A constructor method is used to initialize the objects. They are special types of methods and behave the same name as the class. A constructor has various advantages attached to it. It is invoked automatically as soon as the object of a class is created. This is popularly known as the automatic initialization of objects. The constructor also guarantees that the object undergoes proper initialization before being used. This can be deemed as one of the OOPS tricky interview questions. Make sure you prepare these OOPS interview questions for freshers thoroughly so that you can answer with confidence. Moving to question number 9. List the various types of constructors. Multiple types of constructors that are supported across multiple object-oriented programming languages are default constructor, copy constructor, static constructor, private constructor, and parameterized constructor. Question number 10. What is a destructor? A destructor is a method used for freeing up the resources allocated to an object. This method is automatically invoked when an object is being destroyed. The destructor is used to destroy the objects when they are no longer in use. When the object is being destroyed, the destructors are called. Overloading is not allowed. Moreover, they indulge in releasing the memory. The destructors can never be static and they have no return type. Question number 11. What is meant by a copy constructor? A copy constructor helps in cloning objects by replicating the values from one object into another object that belongs to the same class. It is a special constructor which is used to make a copy of existence during initialization. Whenever the object is passed to a function, an exact copy of that particular object is created and given to the function. Question number 12. Highlight the difference between a class and a structure. Classes and structures are both user-defined data types that allow you to group related variables and functions together. But they have some key differences depending on the programming language you're using. Here, I'll highlight general differences between a class and a structure with specific references to languages like C++ and C#. Question number 13. Explain the concept of inheritance with an example. Inheritance is a powerful feature of object-oriented programming that allows classes to inherit properties and methods from other classes. This helps improve code reuse. For example, a base class represents a logical concept such as vehicle that may define only the common properties shared by all types of vehicles. However, child classes can inherit from this base class to define more specific types of classes such as truck, a car, or a bus. In this case, the child classes will inherit the common attributes of the vehicle and will be able to define attributes and methods specific to its own. Question number 14. What are the limitations of inheritance? The inheritance requires more processing time for the programs as they have to navigate various classes during execution. Due to inheritance, the parent and child class are tightly coupled. When any changes are needed in the logic, it may require changes in both parent and child classes. If the inheritance is not correctly implemented, it can lead to undesired results. Question number 15. What are the various types of inheritance? First, we have single inheritance. In single inheritance, a class inherits properties and behavior from only one superclass or a parent class. This means that a derived class extends a single base class. For example, class B inherits from class A. Then we have multiple inheritance. Multiple inheritance allows a class to inherit properties and behavior from more than one superclass or parent class. When a derived class inherits from multiple base classes, it can encounter problems like the diamond problem. This issue arises when ambiguity occurs because two parent classes have a method with the same name. Some programming languages, like Java, do not support multiple inheritance for classes but may support it for interfaces. Next, we have multi-level inheritance. In multi-level inheritance, a class serves as a derived class in one relationship and a base class in another. This creates a chain of inheritance where a subclass inherits from a superclass and another class further inherits from this subclass. For instance, class C inherits from class B, which in turn inherits from class A. Next, we have hierarchical inheritance. In this case, a single base class acts as the origin of multiple classes. This means that more than one subclass extends the same superclass. Each subclass inherits the properties and behaviors of the common superclass but can have its own unique characteristics. For example, class B and class C both inherit from class A. Then we have hybrid inheritance. Hybrid inheritance is a combination of two or more types of inheritance. It can combine any of the above inheritance types: single, multiple, multi-level, or hierarchical within a single program. Question number 16. What is the meaning of hierarchical inheritance? When multiple subclasses inherit a base class, it is called hierarchical inheritance. The derived class can act as a base class for the new derived class. The higher in the hierarchy the class would be, the more general information it would contain. Question number 17. Distinguish between multiple and multi-level inheritances. Multiple inheritance enables a class to inherit features from more than one parent class, forming a structure with multiple parents, which can lead to complexity and potential issues like the diamond problem. It is fully supported in languages like C++, but has limited or no support in Java and C#, where interfaces are used instead. On the other hand, multi-level inheritance creates a chain-like structure where the class inherits from another class sequentially, making it less complex and easier to manage. Multi-level inheritance is commonly supported in most OOP languages such as C++, Java, and C#, and is typically used to model hierarchical relationships where classes represent different levels of abstraction. Question number 18. How do you define hybrid inheritance? Hybrid inheritance is a type of inheritance in object-oriented programming that combines two or more different types of inheritance, such as single, multiple, multi-level, or hierarchical inheritance within a single program. It allows for more complex relationships between classes, but can also introduce challenges like ambiguity, which needs careful management. Question number 19. What is a subclass? A subclass, also known as a derived or child class, is a class in object-oriented programming that inherits properties and behaviors from another class called the superclass or the parent class. The subclass can extend or modify the inherited attributes and methods and can also introduce its unique features. Question number 20. Define a superclass. A superclass implies a class from which other classes inherit. Example, the vehicle will be referred to as a superclass of classes car, bus, or truck if they are all inherited from the same superclass. Number 21. What is meant by an interface? An interface allows the declaration of methods without providing a definition. You cannot create objects from the interface. When a class implements an interface, it needs to implement the methods provided by the interface. With the interface implementation, a class can perform a role that is different from its class hierarchy. It also provides a standard set of methods for a group of classes. The objects in these classes can be accessed using a standard set of methods without concerning the location in class hierarchy. An interface is of high importance to achieve abstraction. The functionality of multiple inheritance can be supported. Moreover, it is possible to attain loose coupling using the interface. OOPS coding interview questions like this should be elaborated and must make a mention of some importance the function performs. Question number 22. What is polymorphism? Polymorphism is a significant feature of object-oriented programming. It means an ability to exist in multiple forms. A single interface can be implemented in multiple ways by providing various definitions. Question number 23. What is meant by static polymorphism? The static polymorphism or static binding allows us to link a function with objects during compilation. It can be implemented by method overloading or operator overloading. Question number 24. What is meant by dynamic polymorphism? A dynamic polymorphism or dynamic binding allows for a call to an overridden method at the runtime. Question number 25. What is method overloading? One of the most common OOPS interview questions. Method overloading is a very useful feature of object-oriented programming in which multiple methods can have the same method name. However, they have different arguments. The call to the method is resolved based on the arguments. Question number 26. What is the meaning of method overriding? Method overriding allows the child class to redefine the methods of the parent class by applying its implementations. However, the method name, arguments, and the return type remain the same. Question number 27. Can you explain what operator overloading is? The term operator overloading means that depending on the argument passed, the operator's behavior can be changed. However, it works only for user-defined types. Advantages of method overriding only possible in derived classes. The method must be a non-virtual or static method for overriding it to happen. It is helpful to override or change the functionalities. It is used to implement the runtime polymorphism. Question number 28. How do you explain the difference between overloading and overriding? Overloading a method means that multiple methods share the same method name but having different arguments. However, in the case of overriding, the child class can redefine the implementation of a method by retaining the same arguments. Another difference is that the overloading is resolved at compile time while overriding is resolved at runtime. Question number 29. What do you know about encapsulation? One of the most common OOPS interview question. Encapsulation is an important feature of object-oriented programming. It allows the binding of the data and the logic together in a single entity. It also allows the hiding of data. Question number 30. What is meant by data abstraction? Data abstraction refers to the ability of object-oriented programming that allows hiding the implementation details of logic yet allows for access to only important information. Question number 31. How can data abstraction be accomplished? Data abstraction can be accomplished in object-oriented programming by using abstract classes and interfaces which define abstract methods without implementation. That must be implemented by derived classes. Additionally, encapsulation helps achieve data abstraction by hiding the internal details of an object and exposing only the essential features through public methods, allowing users to interact with the object without needing to understand its complex internal workings. Question number 32. What is meant by abstract class? Any OOPS interview questions and answer guide won't be complete without this question. An abstract class is made of abstract methods. The abstract methods are only declared, however, not implemented. When a subclass needs to use the methods, it needs to implement those methods. Question number 33. You could be asked, can you please elaborate on access specifiers? Supporting this OOPS interview question answer with examples, access specifiers are special keywords that control the accessibility of methods or classes. They are also called access modifiers and are used to achieve encapsulation. Example, the keywords public, private, and protected are some examples of access specifiers. Question number 34. How do you create an instance of an abstract class? You cannot create an instance of an abstract class since it lacks implementation logic in its methods. You first need to create a subclass that implements all the methods before an object can be initialized. Question number 35. What is a virtual function? A virtual function is a function in a base class that is declared using the keyword virtual and is designed to be overridden in derived classes. It allows derived classes to provide a specific implementation of the function that is different from the one provided in the base class. When a virtual function is called through a pointer or reference to the base class, the version of the function in the derived class is executed, enabling dynamic or runtime polymorphism. Question number 36. What is a pure virtual function? A pure virtual function is only declared in the parent class. It is also referred to as an abstract function. Pure virtual functions do not contain any definition in the base class. They must be redefined in the subclass for the implementation needed. Question number 37. Distinguish between data abstraction and encapsulation. Data abstraction focuses on showing only the functionality to the user, reducing code complexity by using abstract classes and interfaces, and addressing problems at the design level by focusing on what an object does rather than how it does it. Encapsulation, on the other hand, binds data together into a single unit, hides data for protection by making data members private and accessing them through public methods, and solves problems at the implementation level by concealing the internal mechanics of how an object operates. Question number 38. What are the differences between interfaces and abstract classes? It is one of the general OOPS interview questions and answers guide. An abstract class can support both abstract and non-abstract methods. However, the interface allows only abstract methods. In the case of an abstract class, both final and non-final variables are supported. However, the interface has variables that are by default defined as final. Interfaces support multiple inheritances and do not contain data members or constructors, featuring only incomplete members with no static members allowed. In contrast, abstract classes do not support multiple inheritances, but they do contain data members and constructors, and can have both complete and incomplete members, with only complete members being static. Question number 39. What is a final variable? A final variable is a variable in programming that once assigned a value cannot be changed or reassigned. In other words, it becomes a constant, and any attempt to modify its value after initialization will result in a compile time error. Final variables are often used to define constants that should remain unchanged throughout the program. Basically, a final variable is a variable whose value doesn't change. Question number 40. What is meant by an exception? An exception is an event raised during a program execution caused by undesirable input or condition that prevents further processing. An exception causes an interruption in the program's normal execution and must be handled via exceptional handling logic to avoid the program's termination. A runtime error in the program causes it. It is an event that occurs during the execution of a program. It is identified as an event that disrupts the normal operation or flow of the program's instructions. There are various advantages attached to the exception handling, such as maintaining the proper and normal flow of the program. It does so by separating the error-prone code from the normal code. Moreover, clarifying the code and removing any errors, increasing the readability of the code altogether. Question number 41. Define exception handling. Exception handling is a programming mechanism used to manage and respond to runtime errors or unexpected events that disrupt the normal flow of a program's execution. It involves using try-catch blocks or similar constructs to catch exceptions and execute specific code to handle them, ensuring the program can continue running or terminate gracefully without crashing. Question number 42. Is an error the same as an exception? No, an error is not the same as an exception. An error generally refers to serious issues that arise during the execution of a program, often related to system-level problems, example, memory overflow, hardware failures, and are usually not recoverable. In contrast, an exception is a condition that occurs due to issues like invalid input or logic errors, which can be caught and handled within the program using exception handling mechanisms, allowing the program to recover or continue running. Question number 43. What is a try-catch block? A try-catch block is used for exception handling. The set of statements that may cause a potential error is enclosed in a try block. When an exception is raised, it is caught by the catch block. The logic to handle an exception is placed inside the catch block. Question number 44. What is a finally block? A finally block is a block of code in programming that follows a try-catch statement and is always executed regardless of whether an exception was thrown or caught. It is typically used to perform cleanup operations such as closing files, releasing resources, or resetting variables, ensuring that these tasks are completed even if an exception occurs. Features of finally block: it is used to execute important code. It is always executed whether the exception is handled or not. It should be the last block of execution. It contains all important and crucial statements, whether the execution happens or not. Question number 45. What is method finalize used for? The finalize method in Java is used as a cleanup mechanism that is called by tGarbage collector before an object is destroyed. It allows an object to perform any necessary final operations, such as releasing resources or closing connections before the object is removed from memory. However, finalize is rarely used in modern programming due to its unpredictability and availability of more reliable resource management techniques, such as try with resources or explicit resource cleanup. Question number 46. What is garbage collection and how does it work? Garbage collection is the ability of the programming language to perform automatic memory management. It automatically frees up the memory by removing the objects that are no longer required. Question number 47. Should you always use object-oriented programming? Are there any limitations of object-oriented programming? This is one of the advanced OOPS interview questions and answers. Though object-oriented programming offers many advantages, it has some disadvantages too. Know this when preparing for answers for OOPS concepts interview questions for freshers. First of all, it has a steep learning curve compared to procedural programming. It may take a while to get used to thinking and programming in terms of objects for many people. Secondly, it may take more experience to design a program in terms of objects. Using OOPS concepts for smaller programming tasks may not be efficient. Question number 48. What are the important object-oriented programming languages? Some of those programming languages are Java, known for its platform independence, extensive libraries, and versatility in applications like web, mobile, and enterprise systems. Then we have C++, offers high performance capabilities and advanced features and is used for system-level programming, gaming, and resource-intensive applications. Then C#, integral to Windows development, focuses on productivity and seamlessly integrates with Microsoft technologies. Next, we have Python. While not exclusively OOPS, it supports OOPS paradigm known as simplicity, readability, and versatile applications. Next, we have Ruby. Renowned for its elegant syntax and powers of web applications, particularly through the Ruby on Rails framework. Then we have Swift. Designed by Apple, emphasizes safety and performance, commonly used for iOS and Mac OS app development. Next, we have Kotlin. Adopted for Android app development, modernizes Java with concise syntax and advanced features. Then we have JavaScript. Primarily for web development, it supports OOP through prototype-based inheritance, widely used in front-end and back-end development. Then we have PHP. Mainly used for web scripting, has evolved to include OOPS features integral for server-side web applications. These languages embrace OOP principles, offering encapsulation, inheritance, and polymorphism, enabling developers to build well-structured, maintainable, and scalable software solutions across various domains. Question number 49. What are the limitations of OOPS? Object-oriented programming brings numerous benefits but also has limitations that developers should be aware of. Here are the limitations presented in bullet points. First, complexity. OOPS can lead to complex and integrate code structures, especially in larger projects, making it harder to understand, maintain, and debug. Then we have performance overhead. The abstraction and encapsulation layers in OOPS can introduce performance overhead due to additional function calls and memory allocation, impacting execution speed in performance-critical applications. Next, learning curve. OOPS concepts like inheritance, polymorphism, and design patterns might have a steep learning curve for newcomers, potentially slowing development. Overhead in small projects. For small-scale projects, the overhead of implementing full OOPS principle might outweigh the benefits, resulting in unnecessary complexity. Then we have limited hardware. Utilization OOPS focus on encapsulation might hinder control over hardware, crucial in systems programming and certain performance-sensitive applications. Not ideal for all domains. Some domains like real-time systems or low-level programming require precise control over memory and resources, which might conflict with the abstraction layers of OOP. Next, we have versioning and compatibility. Inheritance and class hierarchies can make versioning and backward compatibility challenging, potentially leading to maintenance difficulties. Next, we have verbose syntax. OOPS languages can sometimes lead to verbose code, making it harder to express certain concepts succinctly. Performance in concurrency. OOPS might face challenges in concurrent and parallel programming, as managing shared state and synchronization can be complex. Understanding these limitations helps developers make informed decisions about whether to adopt OOP or explore alternative programming paradigms based on specific requirements of their projects. Lastly, question number 50. How does C++ programming language support polymorphism? C++ supports polymorphism through its features of virtual functions and function overriding, which are key components of object-oriented programming. It also allows things of varied classes to serve as objects of an ordinary base class, providing a way to achieve dynamic behavior and flexibility in code execution. Here's how C++ achieves polymorphism. First, through inheritance. Polymorphism often involves a base class, also known as parent class, and derived classes or child classes that inherit from the base class. The derived classes can have their implementations of functions, including those declared in the base class. Then we have virtual functions. In the base class, you can declare functions as virtual. This indicates that derived classes can override the function. Virtual functions have a special property that enables dynamic binding at runtime. Next, we have function overriding. In the derived classes, you can provide new implementations for virtual functions declared in the base class. The derived class achieves this using the same function signature. Then we have dynamic binding. When a virtual function is called through a pointer or reference to the base class, the actual function to be executed is determined at the runtime based on the object's types. This is called dynamic binding, ensuring that the appropriate overridden function of the derived class is invoked. If you're interested to learn more about full-stack software development, check out UpGrad and IIIT Bangalore's Executive PG program in software development, specialization in full-stack development, which is designed for working professionals and offers 500 plus hours of rigorous training, 9 plus projects and assignments, IIIT Bangalore's alumni status, practical hands-on capstone projects, and job assistance with top firms. And with that, we've wrapped up our 50 OOPS interview questions and answers. I hope you found this video helpful. If you did, don't forget to give it a thumbs up and like the video. If you have any questions, feel free to drop them in the comments below. We believe that every individual has a unique path to success, and sometimes all it takes is a little guidance to unlock your full potential. Our expert career advisors are ready to help you discover the path that's perfect for you. Don't miss out on this chance to invest in your future. Click the link in the description below to book your free counseling sessions now, and let's start building the career you've always dreamed of. Thank you for watching, and we'll see you in the next one.